Hello, and welcome to this 11th set of problems on logarithms. In this set, we will solve problem number 101 to 110. This is the second last, not second last, penultimate set of problems on logarithm. After this, there will be one more set, and then we will end the problems on logarithm. So, as always, I'll say that when I'm stating the problem, you should pause the video and try to solve the problem yourself. If you cannot solve the problem yourself, only then look at the solution. So without further delay, let's get started. Problem 101 says that solve x to the power log of x with base 10 greater than 10. So we take log of 10 on both sides. Left hand side becomes log of 10x into log of 10x greater than 1. That is log of x with base 10 whole square greater than 1. So the ranges would be that log of x with base 10 less than minus 1 and log of x with base 10 greater than 1. So when it is less than minus 1, x would be less than 1 by 10. But x has to be greater than 0 for logarithm to be defined. So one range would be 0 to 0.1. And when it is log of x with base 10 greater than 1, then x has to be greater than 10. So second range is 10 to infinity. Problem 102 says that solve log of 2 with base x, log of 2 with base 2x into log of 4x with base 2 greater than 1. So here we write log of 2 with base x as reciprocal, that is 1 by log of x with base 2. We also write log of 2 with base 2x as reciprocal, that is 1 by log of 2x with base 2. And we write log of 4x with base 2 as log of 2 square x with base 2. Product is greater than 1. So here we write log of 2x with base 2 as log of 2 with base 2 plus log of x with base 2. That is, we split out 2 and x. And here we split 2 square and x, we get 2 plus log of x with base 2 in numerator, and the product is greater than 1. Now we let log of x with base 2 as z, then we get 1 by z into 1 by 1 plus z into 2 plus z greater than 1. So denominator will become z square plus z and numerator will be 2 plus z. So if we bring all of this on one side, then it becomes z square minus 2 less than 0. That means z should lie between minus square root of 2 and square root of 2. However, for logarithm to be defined, x should be greater than 0. We can see that here. Here with 4x. And 2x cannot be equal to 1 because it's the base of the middle term. So that means x cannot be equal to half. So range would be 2 to the power minus square root of 2 comma half, and then half comma 2 square root of 2. Note that these two are open intervals. Problem 103 says that solve log of x with base 2, log of 2x with base 3 plus log of x with base 3 into log of 4x with base 2 greater than 0. So here what we do is we exchange the base of first two terms. So it becomes log of x with base 3, log of 2x with base 2 plus log of x with base 3 plus into log of 4x with base 2 greater than 0. Now we take log of x with base 3 common. So 2x can be written as log of 2 and log of x, and 4x can be written as log of 4 plus log of x. So log of 2 with base 2 is 1 and log of 4 with base 2 is 2. So 2 plus 1 is 3 here, and then we have 1 log x here, 1 log x here, that becomes 2 log x with base 2. Now if you observe this, it can be true if both log x with base 3 and 3 plus 2 log of x with base 2 are both negative or both positive. So if log of x with base 3 greater than 0, then x has to be greater than 1. And then 3 plus 2 log of x with base 2 has to be greater than 0. That is, x is greater than 2 to the power minus 3 by 2. So combining these two, we find that x should be greater than 1. Now if log of x with base 3 less than 0, that means x is less than 1. and 3 plus 2 log x with base 2 is less than 0. That means x is less than 2 to the power minus 3 by 2. So if we combine these two, we get x is less than 2 to the power minus 3 by 2. So in second case, x should be greater than 0, or rather not in second case. It is a general case that x should be greater than 0 for logarithm to be defined. So first range will start from 0 and will go up to 2 to the power minus 3 by 2. And then in second case, we have x greater than 1. That means second range would be 1 to infinity. Problem 104 says that find the value of log 60 with base 12 if log 30 with base 6 is equal to a and log 24 with base 15 is equal to b. So here we write 60 as 2 square into 3 into 5 and 12 as 2 square into 3. So we get 2 plus log of 3 with base 2 plus log of 5 with base 2 divided by 2 plus 2 into log of 3 with base 2. Now we say that log of 3 with base 2 is equal to x and log of 5 with base 2 is equal to y. So log 60 with base 12 becomes 2 plus x plus y by 2 plus x. Now we are given that log of 30 with base 6 is equal to a. So we write this as log of 30 with base 2 and log of 6 with base 2. 30 is 2 into 3 into 5 and 6 is 2 into 3. So it becomes, we follow similarly, it becomes 1 plus x plus y by 1 plus x. And similarly for b, that is log of 24 with base 15, we split this with base 2 and then it becomes 3 plus x by x plus y. Now we have two equations in x and y. So we solve for x and y, we will get b plus 3 minus ab by ab minus 3 and y would be 2a minus b minus 2 plus ab by ab minus 1. Once we have these values of x and y, we can substitute for log 60 with base 12. We will get end result as 2ab plus 2a minus 1 by ab plus b plus 1. Problem 105 says that if log of x with base a, log of x with base b and log of x with base c be in AP and x not equal to 1, prove that c square is equal to ac to the power log of b with base a. So since they are in AP, we can write that 2 into log of x with base b is equal to log of x with base a plus log of x with base c. Now we write them in the form of reciprocals, so the base and the number get exchanged. We get 2 by log b with base x is equal to 1 by log of a with base x plus 1 by log of c with base x. We take LCM on right hand side and so we obtain 2 log of c with base x. We take this log of c with base x, we get it here, and this term in numerator becomes log of ac with base x. This log of bx goes to numerator here, log of b with base x, and this log of a with base x remains in denominator. So from this we can write that log of c square with base x is equal to log of x ac, and this becomes log of b with base x. So we can say that c square is equal to ac to the power log of b with base a. This should be whole to the power, not c to the power. There should be parenthesis for clarity. Problem 106 says that if a is equal to log of square root of 0.125 with base half and b is equal to log of 1 by square root of 24 minus square root of 17 with base 3, then find whether a is greater than 0, b is greater than 0 or not. So a is log of square root of 0.125 with base half, and both the number and the base are less than 1, so a will be greater than 0. In the second case, we can write 1 by square root of 24 minus square root of 27 as square root of 24 plus square root of 17 by 7. That is, we multiply and divide with square root of 24 plus square root of 17. Now we see that square root of 24 is more than 4 square. That is, it is greater than 4. And square root of 17 is more than 3 square. That is greater than 3. So the sum would be greater than 7. So the number and the base both are greater than 1, so the logarithm would be greater than 0. Problem 107 says that which one is greater among cos of log theta with base e or log of cos theta with base e if e to the power minus pi by 2 is less than theta, which is less than pi by 2. So we are given that e to the power minus pi by 2 is less than theta, which is less than pi by 2. So we take log natural, that is log with base e. So it becomes what is given here. And then the first term becomes minus pi by 2. The second term remains log theta with base e, and log of pi by 2 with base e is less than log of e with base e. So this means that uh, this is less than pi by 2, and pi by 2 is greater than 1, so we can write that log theta with base e is less than 1. So now we see that minus pi by, sorry, I misread this. So log of pi by 2 is less than log of e with base e. So we have this and we have this condition. So we see that this would be less than log of e with base e, and this is 1. So we write instead 1 here, and 1 is less than pi by 2. Now we have minus pi by 2 less than log theta with base e less than pi by 2. Now if we take cos of this, then in this range minus pi by 2 to pi by 2, cos of that angle is greater than 0. That is, cos of log theta with base e will be greater than 0. And we write the condition again. Now e to the power minus pi by 2 is greater than 0, so we can write this as 0 is less than theta, which is less than pi by 2. Now if you take cos theta in this range, then the range would be 0 and 1. The limits of the range would be 0 and 1. So we can, if we take log of this, then log of cos theta would be less than 0 in this range. So we can say that cos of log theta with base e is greater than log of cos theta with base e. Problem 108 says that if log of x with base 2 plus log of y with base 2 is greater than equal to 6, prove that x plus y is greater than equal to 16. So we are given that log of these two terms sum is greater than 6. So equivalently we can write log of xy with base 2 is greater than equal to 6. That is, xy greater than equal to 64. 2 to the power 6 would be 64. So since x and y will be both positive in this case, because negative values if we choose for either x or y, then the logarithm will be invalid. Now we know that arithmetic mean is greater than equal to geometric mean. So x plus y by 2 would be greater than equal to square root of xy. So now square root of xy is square root of 64, that is 8. So 8 into 2, x plus y is greater than equal to 16. Problem 109 says that if a, b, c be three distinct positive numbers, each different from one, such that log of a with base b into log of a with base c minus log of a with base a plus log of b with base a, log of b with base c minus log of b with base b plus log of c with base a, log of c with base b minus log of c with base c is equal to 0, then prove that abc is equal to 1. So here we are given this, and what we do is we write the logarithms in form of ratio. So this becomes log a into log a in numerator, because both are logarithm of a, and in denominator it becomes log of b into log of c, where b and c are bases, and log of a with base a can be written as 1. Similarly, the third term becomes log of b whole square by log of a into log of c, and the fourth term is log of b with base b, which is 1. And fifth term becomes log of c whole square by log a into log b minus 1 is equal to 0. Now we let log of a is equal to x, log of b is equal to y, and log of c is equal to z. So what we have is x square by yz plus y square by zx plus z square by xy minus 3 is equal to 0. We take LCM, we get x cube plus y cube plus z cube minus 3xyz by xyz is equal to 0. Now the numerator can be written as x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx, which can be equivalently written as x plus y plus z into half into, in the brackets, x minus y whole square plus y minus z whole square plus z minus x whole square is equal to 0. Now since x, y, z all are different, that is different from 1, the value inside brackets would always be greater than 0. So what we can conclude is that x plus y plus z is equal to 0. Now since these are 0, we can write that log a plus log b plus log c is equal to 0. Now apply the formula on this and we get log ABC is equal to 0, that is ABC is equal to 1. Problem 110 says that if y is equal to 10 to the power 1 minus log x and z is equal to 10 to the power 1 by 1 minus log y, prove that x is equal to 10 to the power 1 by 1 minus log x. So here we are given y is equal to 10 to the power 1 by 1 minus log x. So we take log, we get log y is equal to 1 by 1 minus log x. And we are given that z is equal to 10 to the power 1 by 1 minus log y. So we take log, we get log z is equal to 1 by 1 minus log y. We exchange this and we can write that log y is equal to 1 by 1 minus log z. So here we have one value of log y, we have one value of log y here. So equate them, we get 1 by 1 minus log x is equal to 1 minus 1 by log z. So now we solve for log x. Here we get log x as 1 by 1 minus log z. So we can write that x is equal to 10 to the power 1 by 1 minus log z. So with this, we come to the end of 11th set of problems on logarithm. And I hope that you have found this video useful. Please subscribe to the channel and like the video so that it reaches to more students like you. If you have a comment or a question or you want to talk about anything, please make use of the comment box. Thanks a lot for watching. Enjoy.